Should I go through the whole thing? Yeah, why not? Less I have to do next time. Okay. We're at a store. The store has a 30% off of everything sale. So basically what you want is a function that just tells you how much the people need to pay you. Well, at least how much you're going to charge them for that item when it's 30% off. So how do you find 30% off of money, items? 8th grade question. Multiply whatever it is by 0.3. That's it?
No, and then you take that and
Subtract away from whatever it was to begin with.
Yeah.
So what do we call whatever it is what you begin with algebra?
G of X.
Okay, no, X. Just X, plain old X. So you're going to take 0.3 of X, whatever X is, right? $100, $50, $75, whatever it is. And you're going to take that away from the original price, which was X to begin with. So my question to you is, what's X minus 0.3X? I love this question, really I do. It's amazing how many people look at this and go, oh my god, it must be hard. But if I said, what's X minus 3X, you'd all get the right answer. I hope. Please. What's X minus 3X? What's X minus 3X? Not 0.3X. What's X minus 3X? Oh my god. Negative 2X, thank you. So, what's X minus 0.3X? 0.7X. I know, but no one else got it. You were the only one that said it. Everybody else is like, what? This is $1 minus 30 cents. 70 cents. $1. $1. Whoa, is she whispering it?
She was saying it.
I love whisperers. I can't hear whispering. I'm old.
She was saying it too, but you just...
I'm like 55 years old.
Oh, please.
You're a bully.
My dad's older than you are.
I know. So this is my function. I'm going to call this g of x. This function, if I put the sale price in, it'll take 70% of the price, which will give me back 30% off. So when you're doing sales, you don't care about how much money you're saving. You should only care about how much money you're spending. So if it's 30% off, it's 70% of the price. If it's 20% off, it's 80% of the price. Those two numbers should always add up to 1. All right. Next function. Find f of x, a function that adds 7.5% tax, sales tax. All right. So how do you do 7.5% sales tax? And you get 0.075.
You do that 1.575 minus.
Oh, but where does it come from?
I don't know
Mess.
that other stuff that I used to fail.
You would take 0.075 and you multiply it by the cost, and the cost we're going to call x, so it's 0.075x, and then you're going to add that back to x, the cost. We did this before, didn't we? That seems familiar. And what's x plus 1? What's x plus 0.075x? 1.075x. And we're going to call this function f of x. Okay. So far, so good? I'm going slow enough for y'all? So, let's say we let x equal $75. So G of $75 will tell you how much the item costs on sale. So what is 0.7 times 75? You all have calculators, I don't. Well, I do, but it's in my bag, and I'm not going to give it to you.
Okay.
That's fine.
What is it, 0.7 times
0.7 times 75.
52.5.
52.5. So this would be $52.50. That would be its sale price. Now you have to go up to the cash register and pay for it. Are you going to get taxed on $75? I hope not. They can only tax you on the sale price, which is $52.50. So when you come down here, I'm going to do F of $52.50. So that's going to be 1.075 times $52.50.
It'll be 54.
I just made it up.
Okay.
I went to the store and I bought $75 worth of
Just make
merchandise.
sure, make sure.
What is it?
54.25. I'm just kidding. I really don't know.
Ah.
56.4.
What is it?
56.4.
56.4 even?
Well, 44, you rounded up. It's 4375, so it'd be 44.
44. All right, so it'd be $56.44. Great, except for one problem. Too many calculations to find out the total price at the end of the day. So if you look at this right, you can see what's really happening. You're finding G of 75 and you're taking that answer and you're plugging it directly into F. If you ever taken a science class, especially chemistry, you always find out one answer. You take that answer and put it into another formula to find out your final answer. That's what's called a composition of functions. So what I'd rather do is come up with one function that does both of these calculations simultaneously at the exact same time. We call that function FOG, little o. It's called composition function. It's not times, it's an open circle, but it's kind of small. This is called fog notation. You do not want things in fog notation because it's very confusing. So to change it, you're going to write it as this, f of g of x. And that's basically what happened over here. We did f. The 5250 was g of 75. So this would be f of g of 75, if you want to think of it that way. So it's the exact same notation. But I want to do this with x involved and not the number 75. And then we'll test it out with 75 and make sure it works. So what's happening here? Well, f, you're plugging in g of x into it. So g of x is going inside of f. Well, what's f look like? Well, f is over here. F looks like 1.075 times x. Well, what's x in this case? Well, x in this case is whatever's on the inside, which happens to be g of x. Well, what's g of x in this case? Well, g of x is over here. There it is. G of x. It's 0.7x. So in here I'm going to put 0.7x. So it's f on the outside and g on the inside. So this is f of g of x, which is equal to, well, now I can simplify it. What's 1.075 times 0.7? 0.7525x. Now let's test it out. What is f of g of 75? Well, that's 0.7525 times 75. And I guarantee you the answer is 5644. Am I right? Yeah. So instead of doing this calculation to come up with the sale price, taking the sale price and plugging it into this function and getting the total cost after taxes, I just plugged it in once and got my total cost after taxes. One fell swoop and I've gotten to my final answer. So that's what it means to be a composition of functions. You're trying to reduce the number of things that you're plugging back into. Does it get hard?
Yes.
Sometimes. Do I have time? I got 7 minutes. So, for instance, let's start off with simple. Two simple functions. What's the domain of both of them? polynomial. They're linear if you really want to be specific. I want to find f of g of x. So what function do you look at first, the f or the g? What function is getting plugged into? Am I plugging g into f or am I plugging f into g?
F
Am I plugging f into g?
G.
G into f. You got to read it backwards. G of x is in place of x, so it's replacing, substituting the value of x. This should be f of x. So g of x is getting plugged into f. So when you read composition of functions, you actually read it going backwards. The inside gets done first, then the outside. But when you go this direction, you start with, what does f look like? Well, f looks like 2 times something minus 3. Now remember the language of functions. Whatever goes in the parentheses next to f goes into the empty set of parentheses that are on the right. Well, what goes over here then? Well, g of x is in here. G of x better go in here. G of x. F of a would be 2 times a minus 3. F of b would be 2b minus 3. F of g of x is going to be 2 times g of x minus 3. But I know what g of x is equal to. What's g of x equal to? 4x plus 7. So I can substitute 4x plus 7 in for g and get that expression. And then simplify. So this becomes 8x plus 14 minus 3. I'm going to go so fast on Wednesday, it's going to twirl your heads. Plus 11. 14 minus 3. So this is a new function called f of g of x. The composition of f and g. All right. So does that mean I'll get the same answer if I do this? What? Golf, in other words. Will I get the exact same answer?
No.
The answer is absolutely not, or always not, or sometimes not. Sometimes not. Sometimes they actually are equal. That's a special case. We'll talk about that next time. Yay! So, if I do g of f of x, what function do I look at first? F is getting plugged in. I need a skeleton form. So the one I want to look at is g. So g looks like 4 times something plus 7. What's the something? The something is not 4x plus 7. That's the skeleton part. That's the g. The something is f of x. So you plug in f of x here. But that's going to get simplified. So this becomes 4 times whatever the heck f of x is equal to plus 7. Well, what's f of x? 4x minus 3. And you simplify this one. This becomes 8x minus 12 plus 7. Better known as minus 5. So this would be g of f of x. So generally, f of g of x is different than g of f of x, except for that one special case, which we'll talk about next time, which is really important. So what happens on the test? I'll ask the first one, f of g of x, and people will answer me the last one, g of f of x. Is it right? No. So you have to be really careful. Which function is the skeleton? Which function is the inside? And literally, it's on the inside, so it should give you a hint.
So the question on the test is going to look more like example 2, what the one you just did.
Oh, actually worse than that.
But it's going to give us an equation and then...
I'll give you the 2 functions. I'll say compose them. And you better know how to compose them. How much worse can it get?
Good Lord.
Do not ask that. Let me show you a simplistic version of what's worse. I got 3 minutes. Simplistic version. Here's 2 functions. Both of them rational. Domain of the first one. Simplistic domain, not the interval domain. I woke up. Domain of the first one. No.
No, it's negative infinity.
I don't want intervals. Just tell me what it can't be. I said simplistic.
Three, positive three.
Cannot be 3. What can the second one not be?
Negative.
-1. Just keep those in the back of your head. The first one can't be 3. The second one can't be -1. And I'm going to ask, what is this? It's like one of my favorite questions of all time. Because there's a trick to this one. You have to be really careful with the domain part. So if I ask for g of f of x, that's literally what this reads. G of f of x. What function do I want to concentrate on first? G, the one on the outside. So g looks like 4 times something over something plus 1. Replace all those x's with empty sets of parentheses. In this case, a little bit larger. What goes in the parentheses?
2 over 8
F of x, which is 2 over x minus 3. So 2 over x minus 3, 2 over x minus 3. Stop right here. Just looking at what I plugged in, what is the domain of what I just wrote? X cannot be 3. Can't be 3 there, can't be 3 there. So part of your domain is going to be x can't be 3. Even at the very, very end, after you simplify this expression, x can never, ever equal that number. Ever. Now, how do I simplify this expression? Yeah, that fraction mess.
Just cross it out.
God. Can't cross out with a plus sign in the bottom. What's the other trick? Did it at the beginning of class. No, it's not the common you get. Common denominator. Multiply everybody by the common denominator. What's the common denominator? What's the only denominator?
2 over x minus
No. The only denominator you see out of the fractions inside of x minus 3. So you multiply everybody by x minus 3. Zombies, I know. You multiply everybody by the common denominator, in this case, x minus 3. So when you do multiply by x minus 3, what happens to the x minus 3's in the numerator? What's left over? 8. 4 times 2. Over. What happens to these x minus 3? I could actually cancel them. These cancel, right? What's left? Who said 3? Was that you? That was you. I heard you this time. Plus, what's left over for the other one? Well, it's 1 times x minus 3, better known as x minus 3. All right, and then just simplify. This becomes 8 over x minus 1. So, what is the domain of this new function? Well, x can equal 1, but then you have to go back up here and say x cannot equal 3. You've got to remove both of them. So this is part of your domain, and this one here says x cannot equal 1. That's part of your domain, and you need to put them together. So it's negative infinity to 1, 1 to 3, 3 to infinity is your domain. And this down here is g of f of x. Ta-da.